Big Slick here, and on the bench today is an EICO Model 145 signal tracer, and as you'll see there was some very interesting modifications done to it. We'll have to take it back to original and work from there to solve the problems. Okay, the modifications that some previous owner did, they built some type of standoffs above these tubes here and mounted the output transformer just with a zip tie above here. And then they also put a choke in here for the power supply, and neither one of these modifications are practical. I mean, obviously this mounted transformer like this is amateur hour, and even the filter choke is totally unnecessary, and beyond that it's in very close proximity to the input jacks, so it was likely to only make hum worse, not better. So we're going to revert this back to original and work from there. Right now the unit does work, but it has a hum, doesn't really have enough gain. Okay guys, we're back, and this thing needed rebuilt completely from the ground up, including rewired. It was in a lot worse shape than I thought it was at first glance. I'll show you where it's at this point. Since someone had modified all these inputs, I had to work with what I had here. You'll see that these holes were already drilled, and these were modified, and these were modified here. So what I did was I went ahead and made the 3 inputs here. This one the person already had in there. I added a BNC here, and I added an RCA jack here. And like I say, these holes were already here, so all I did was determine how I was going to fill them. So you have 3 different 1/4 inch BNC and RCA. That provides a lot of flexibility for input. The VTVM jacks, which, you know, this allows you to look at the signal with either a VTVM or oscilloscope. I left this original. This had been highly modified over here too, so I went ahead and used banana jacks here, because for what this does, I think banana jacks would work better here right now, because this allows you, if you want to use it as a test speaker, so that if you just want to utilize the speaker, you can take an amplifier output, plug it into here, and use this speaker as a test speaker. Or if you want to use it as a test amp, in other words, to test speakers out, it's kind of the opposite. You're using the amplifier function here. The output here will allow me to easily use either banana connectors or just regular alligator clips to clip into here and clip onto a speaker and to test small speakers out. That's what we did from the face, but all the work was internally. First I cleaned everything up here and had to add some heat shrink tubing around the AC power switch here. This chassis had substantial modifications, as you saw. I undid them. I put the output transformer back where it originally was, and these up here were modifications. I'm not sure what I'm going to do with these yet, but for now I disconnected them. And as you see, it's a whole lot cleaner than it was before. Added a grounded line cord, because anything with a metal chassis like this really, in my opinion, should be grounded. There are arguments against it, but I'm not really a big fan of that in most cases. So in here, this is actually almost 100% redone, including this socket turned out to break during repairs. These original wafer sockets are very poor quality, so I was able to keep these 2 intact, but this one here had to be replaced. There's a new octal socket here, totally rewired, all new filament wiring. As you see, it's tightly braided and spiraled. I added a I think these are called humdingers, but basically a hum control pot where the center tap goes to ground, and I have it grounding back to the preamp tube here. This allows you to adjust for minimum AC hum, filament-based hum. So that's all redone. New capacitors, I added a line fuse, I added an inrush current limiter, I added a X1Y2 safety capacitor across the line. Every bit of this wiring is redone. I put a new orange drop there, a new cathode resistor, and bypass capacitor. Luckily, this hole had already been drilled here in the back, so that was a great place to mount the humdinger, and it even coincided with a hole in the back of the case. And I'm not sure if that was original or not, but in either event, it was already there, so we were going to utilize it for this. I added extra terminal strips to keep all the AC input wiring nice and neat. And this is going to be quiz time to see if you can figure out. It's a tiny issue that really doesn't affect what this item would be used for in terms of its ability to be an effective piece of test equipment, but it has a small issue yet. Now, I knew what the issue was right away, having encountered stuff like this in the past. This can trip up a new technician, or even a seasoned one who's never run into it, fairly easily. So what I'm going to do here is, this thing is totally cold right now. It hasn't been on for over a day. So what I'm going to do is just put this camera right next to the speaker, and immediately when you plug it in, there's a low-level 60 cycle hum coming out of the speaker. As soon as you hear the hums, that is exactly when I plugged it in. There's a very low level 60 cycle hum. So the question is, why is that hum there immediately when you turn it on? If you'd like to think about it further, pause the video. The answer is, we're getting magnetic coupling somewhere here due to the layout of this design. The proximity of this output transformer to this power transformer is immediately coupling into the speaker. When they made this goofy contraption to elevate this output transformer above these power tubes, and they're just dangling over with a zip tie in it, they may have been on to where the problem was in this unit and just very poorly implemented a solution. Quite possibly, if one of these two transformers is turned, if it's turned directly the opposite, this may solve the problem. Now then the question becomes, can it be implemented that way? And that may be difficult. I'm not sure if turning this sideways I can do that with there being enough room here or not. It's a very tight fit as it is. You just have to kind of play with it upside down, different directions, and then see wherever you get the least hum, can I mount this here feasibly? In case you want to see another example of something like this happening, Mr. Carlson several years ago worked on a Stark signal tracer that also had issues with transformer layout inducing hum. Here is the final location of the output transformer. This exact orientation was the lowest hum level, and it had to be upside down and with the wires facing in. Even turning this upright had slightly more hum, so I mounted it upside down, and it's pretty neatly done. This could probably be done better if you went ahead and replaced the transformers, because it's obvious that the shielding is inadequate on these. It's very good now. It's extremely minimal, to the point where most people would probably not even find it audible. I went ahead and installed a LED instead of the original one, because that wiring had all been changed, and I decided to just go with something a little more permanent. Okay, I'm going to plug it in here in a moment, and you will hear that there is virtually no hum at all now from the inductive coupling. I don't even think that can be picked up on camera, and it is on now. So we made a big improvement there. I'll show a few examples of the unit working now.
Decorated for the holidays, where you can step inside and have a free photo with family and friends. Food Truck Palooza 2021 with Bob FM and Good Taste Pizza. bucks, 15 at the door. Kids 10 and under are free. Sponsored by the all-new Monroeville Kia. Get your tickets now at bobfm969.com.
When you run a business, setbacks change everything. And online, they happen fast. With your Comcast Business Internet, you can stay ahead. And now it comes with Security Edge to make it even more secure.
As you hear, that has plenty of volume and is nice and clear. Okay, now here's an example of tracing in an All-American 5 circuit. This is going to be all the way back at the antenna, which is going to be one of the places where it's going to be hardest for a signal tracer to pull the signal. And of course AM radio, you're going to find people like Brother Stare on here. And there it is, tracing all the way back at the very first tube. So it's working well, and this is using my EICO RF probe. Turn the gain down a little bit and check it over here at the volume control.
For the book, Tree Masonry, written by a former worshipful master.
That's on the high end of the volume control, so that's testing the up to the audio output section. As you see, for that example, I had the volume control all the way down in this All-American 5 radio. That just gives you two quick examples of how you would signal trace a circuit in an All-American 5 radio, and I had this radio plugged into an isolation transformer. And there you go, this is the EICO Model 145 signal tracer that required basically a complete rebuild